So let's take a look at this question that asks us to do a hypothesis test comparing the means of two populations. So here we're given some information about the weight of cans of two types of soda, diet soda in our first sample and regular soda in our second sample. And we can see that we're denoting the mean of the weight for the diet soda for the whole population as mu1, just meaning it's the mean from the first sample. And the regular soda is denoted as mu2, just the mean for the population of the second. The question says, assume the two samples are independent simple random samples selected from a normally distributed population and do not assume that the population standard deviations are equal. Complete parts A and B below. Use a 0.01 significance level for both. Okay. So the first part just wants us to identify the claim. The claim is that the contents of the cans of diet soda have weights with a mean that is less than the mean for the regular soda. So diet soda again was mu1, and the claim is that that mean is less than the mean for the regular soda. So mu1 less than mu2 should be my hypothesis, and that's going to go into the alternative hypothesis H1. Now it might be tempting to look right here and see H1, mu1 less than mu2, and automatically select A. However, be careful, look at the look at the null hypothesis here as well. The null hypothesis here says that mu1 is not equal to mu2, but the null hypothesis should always have an equal sign in it. So it's not letter A. Be sure to check both. It's going to be letter D. Letter D says that the null hypothesis mu1 is equal to mu2, and the alternative hypothesis is mu1 is less than mu2. And that's what we wanted here. The diet soda have weights with a mean less than the mean for the regular soda. So now we need to find the test statistic, and this is very, very easy to do with Statcrunch. So when you open up Statcrunch, as I have over here, what we have to remember is that we're doing a hypothesis test here for two means where we were given some summary information, right? They told us how big the sample was, that's n. They told us the mean of the sample, that's x bar, and they told us the standard deviation of the sample. So in Statcrunch, to conduct this hypothesis test, we're going to go to Stat, T-stats. Now we're choosing T-stats as opposed to Z-stats because remember, the value they gave us here for the standard deviation, it's denoted in the table with a little lowercase s. That means it's the standard deviation from a sample. If this had been a sigma, the O with the little tail on top, that would mean that this standard deviation came from the whole population. And if that were the case, we would have chosen the Z-stats. But in this case, the standard deviation we were given is only from the sample, so we're going to choose T-stats. Now we had two samples in this particular question, right? We had the diet soda and the regular soda. So we're going to choose two sample. And we were given the values of the information not with raw data, but with a little table of summary statistics, right? They just gave us the mean, standard deviation, and sample size for each of the two. So I'm going to choose with summary. If I had been given the raw data, I would choose with data. In this case, we're choosing with summary. So this nice table is going to open. All we have to do is fill in the information from the table we were given. So really quickly here I have filled all those in. Notice all I did was I copied the information from this table into the appropriate fields here for each sample. Now, it says here calculation option pool variances. The only time you're really going to pool the variances is if you were told that the standard deviations from the two populations are assumed to be equal. However, in this case, remember they told us specifically, do not assume the population standard deviations are equal. So we are not going to check this box. Now we're going to do a hypothesis test. The null hypothesis is correct with an equal sign, but remember, our hypothesis for the alternative hypothesis was that mu1 is less than mu2. So right here, I need to select the correct direction for that alternative hypothesis. So I'm going to select less than. And that's it. I can click compute right now. So I've been given the test statistic right here and the p-value right here. So I'm going to go ahead and just copy this test statistic, copy, and go back over here and paste it into my field for the test statistic. Now it says to round to 2 decimal places, so I'm going to go ahead and go back and round it to 2 decimal places and click check answer, and that is correct. Now it's asking for the p-value. The p-value here was so small they had to tell us that it was less than 0.0001. So I'm just going to copy that, and they're only asking for 3 decimal places here. So if I paste it, I literally get this, 0.000. That's what it would be rounded to 3 decimal places. And that is correct. So let's make our conclusion. Now remember, we were using a 0.01 significance level here, and we want to compare that significance level with this p-value and determine which one is bigger. That's going to tell us whether we reject or fail to reject our null hypothesis. So in this case, the p-value is basically 0. It's very, very small, and it is smaller than the alpha value, the 0.01 significance. So when the p-value is smaller than the significance level, that means you are going to reject your null hypothesis. If the p-value was bigger, we would fail to reject. In this case, the p-value is smaller, so we reject. That means automatically I know that the answer here has to be either A or B, because C and D say to fail to reject, and I didn't want to do that. So it's either A, reject the null hypothesis, or B, reject the null hypothesis. If I go back up to my original claim, remember the claim was that the diet soda have weights with a mean that is less than the mean for regular soda. And that was what was denoted right here in my alternative hypothesis. My null hypothesis said that the weights were the same. But based on my p-value, I just decided to reject that null hypothesis. In other words, I have rejected the idea that the weights of the 2 cans are the same. I do not think they're the same. Well, if I don't think they're the same, then my only alternative was this, that the cans for the diet soda were actually less. So I have supported this statement that the cans for the diet soda have a smaller weight. And that was my original claim. So I have supported my original claim. So if I come down here, let's read those and see which one is stating that in the sentence that follows the first statement. There is sufficient evidence to support the claim that the cans of diet soda have mean weights that are lower than the mean weights of the regular soda. Yes, that's correct. The second one says there is not sufficient evidence to support the claim that the cans of diet soda have mean weights that are lower than the mean weights of regular soda. But we did support it. Remember our alternative hypothesis, hard to say that for me for some reason, was that this was the claim, that the diet soda had a mean weight less than the regular soda. Since we rejected the null hypothesis, we supported the second statement, which was our claim. So this is going to be letter A.